Welcome back, students. This is Module 2.3.5. This would be the conclusion of cellular respiration. And we want to sum up this process and remind you kind of the definition that respiration is the basic cellular process by which organisms harvest energy from food. And when they harvest that energy, they transform it into ATP. Virtually every way of dying, every cause of death that you could think of is related to an interruption in the supply of ATP to cells. If someone drowns, then they're not getting enough oxygen and they can't perform aerobic respiration and they don't produce enough ATP and they die. The brain is the most oxygen-consumptive organ, so if someone has had a near-drowning experience or one of those terrible tragedies occur and a child has fallen in a backyard swimming pool, they always check first for brain damage. So the most oxygen-consumptive organs are the ones that need the most energy. The process of respiration may occur aerobically or anaerobically. We learned about two pathways. The aerobic pathway is about 18 times more efficient than the anaerobic pathway. Let's remember where those numbers come from. The aerobic pathway consists of glycolysis, Krebs cycle, and electron transport chain and produces a total of 36 ATPs, while the anaerobic pathway consists of glycolysis and fermentation and produces only 2 ATPs. 36 divided by 2 is 18. So the 18-fold more efficiency is coming from that calculation, if you will. You should recall, of course, that glycolysis precedes aerobic respiration and fermentation. So glycolysis is there in both the aerobic and anaerobic pathways. Aerobic respiration has 2 stages, the Krebs cycle and the electron transport chain. Aerobic respiration is more efficient than your car. Your car is about 21% efficient at transforming the energy in gasoline into motion, while your cells are about 38% efficient at harvesting the energy of glucose and transforming it into ATP that can do useful cellular work. Anaerobic respiration is only 2% efficient, but it does allow life to occur in the absence of oxygen for a while at any rate. Now that you are a little bit more educated about some of these concepts, we're ready to go back to that smoky bar in Nairobi, Kenya, and learn the outcome of Richard Leakey's bet. Let me just show you the outcome of the bet, and then we'll discuss why this outcome was able to occur. There's Richard Leakey. Oh, look, he won. Congratulations, Richard Leakey. Look, he's holding the gazelle right there. Yeah, he got it. So how did Richard Leakey win? The next day, he sat out bright and early, found a herd of gazelle out on the African savanna. And Richard Leakey, you will recall, was raised out in the African bush by his parents. And so he had ample opportunity to learn animal behavior and to observe gazelles up close. And what he did was he singled out the one single large animal, probably an old male with large horns, heavy horns, and probably he would have looked for one that had a limp or some physical malady to make it easier to catch. In any case, he would have focused exclusively on that animal, and he would have walked purposefully but slowly toward that herd. And all of the gazelles would have taken off, just sprinting away, because this is how they escape from predators. And Richard Leakey would not have run, would not have sped up, but he would have just focused on that one gazelle and walked toward it. And they would have gone spring, 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 off, and then they would be in the shade panting after their little sprint. And Richard Leakey would steadfastly walk toward him again. The same thing would happen over and over and over again. This is really a metabolic race in which the gazelles are using the anaerobic pathway, and Richard Leakey is using his aerobic pathway. And so he's getting much more energy for every molecule of glucose. And in the end, all of the other gazelles probably would have peeled off from the herd except for that one animal, and Richard Leakey would have just stayed after the one animal. In the end, he probably did a short little sprint and grabbed it and captured that animal. It's a really interesting phenomenon. This is a little bit of a written summary of the story that I just told. I can tell you that this, in fact, does work from personal experience. Not that I went to and captured a gazelle in Africa, but when I was a little boy, we used to run around at the college campus, the local community college campus in California where I grew up. And one day we were out there and we saw a flock of quail. And we thought, man, these are really cool. And so we said, let's catch a quail. And we didn't know we couldn't catch a quail. And so we went running after this flock of quail, and they all scattered, and we just followed the largest group over and over again until we were really only following one bird. The birds landed up on the roof of the college building. We crawled up there. They got up in a tall pine tree. We threw sticks up there until they flew down. In the end, I actually was able to capture an adult quail that could fly in my hands because it was exhausted from flying. It had been, when quail fly, they do not do so aerobically, they do so anaerobically. Of course, we didn't know that, but we were able to capture the quail. Really a kind of an interesting outcome. In addition to understanding Richard Leakey's bet, I also wanted you to be able to explain and to answer the question, why do we breathe? And here is a brief summary. I will ask you such a question on the exam, why do we breathe? And you should, as a minimum, include the ideas that are on this slide. We breathe to get oxygen. We need oxygen to serve as a final electron acceptor so that we can use the aerobic pathway instead of the anaerobic pathway. The aerobic pathway is much more efficient, producing 18 times more glucose per molecule, 18 times more ATP rather, per molecule of glucose than does the anaerobic pathway. The aerobic pathway consists of glycolysis, Krebs cycle, electron transport chain. The anaerobic pathway consists of glycolysis and fermentation. And you need to be certain to specify the reason we need oxygen is to serve as a final electron acceptor. Anyway, and you should have the ability to elaborate a little bit beyond this, but this is a very minimum. So let us wrap up this lecture, this topic, and tell you that much of the form and function of organisms exists to support cellular respiration. If you think about it, two of your major bodily systems, or several of your bodily systems, I guess, more than two, the pulmonary system, the digestive system, and the circulatory system, they provide oxygen and food and remove carbon dioxide and waste. And of course, your heart is a major pump, and it pumps the blood that carries the oxygen to your cells. And so it's critical to allow to provide food and oxygen to the cells so that ATP can be released and life can be sustained. So cellular respiration is one of the very fundamental biological processes around which life has become organized. Many processes of life, such as cellular work, maintenance, growth, and reproduction, depend upon cellular respiration. This is where energy comes from for things like movement, for growth. This is a candle of a pine tree. This is next year's needles are all in here, so this is a growth that's occurring. For maintenance, here's a lizard shedding its skin, and reproduction. Don't get embarrassed. This is what biology is all about. And we can really sum up some of these ideas in a table, and I think you should be very acquainted with this table for this topic. It's broken down into to a fairly simple level, and I would warn you that this is one topic where reading your textbook could confuse you because the details are much more numerous than I have included. I've simplified this topic to maximize understanding, And I hope you appreciate that. But there's no reason that if you were intent and serious and read very carefully, you couldn't make sense of how what I've told you fits in with the more complicated explanation. It's just that I won't test you at that level of complexity. So you should be very familiar with this table. Here is a little diagram. On the left, it shows the processes of the aerobic pathway, glycolysis, Krebs cycle, electron transport chain. On the right, it shows glucose coming in, and then there's the glycolysis occurs, and there's pyruvate with oxygen. It goes to the Krebs cycle in the mitochondria, and without oxygen in an anaerobic environment. Then it stays in the cytoplasm and undergoes fermentation. In any case, I hope you have a much greater appreciation for breathing, and you can understand why we do in fact breathe. That concludes this module.